Dear students, I, Mr. Vishal Shah, Assistant Professor, Krishna Institute of Pharmacy, Karad, once again welcome you all to this my YouTube channel. Today in this video we are going to discuss about the another session of pharmaceutical analysis, that is the primary standard as well as the secondary standard. In previous few videos we have covered introductory part about the pharmaceutical analysis one, as well as in last video we have covered the different ways by which we can express the concentration, terms that are used for the expression of the concentration. Now in this video we will see two important terms that are used in pharmaceutical analysis or volumetric analysis, that is the primary standard and the secondary standard. Now if you have not watched my previous videos, you can watch my previous videos, and if you like the content of this my channel, then you can subscribe to my YouTube channel as well as you can share with your friends. So let's begin today's session. Before that, just we will see what are the learning outcomes of this our today's session. After watching this video, students will be able to explain the different terms like the primary standard and the secondary standard. In this video, we will in detail see what is the meaning of primary standard and what is the meaning of secondary standard, as well as what is the role of these primary standards and the secondary standard in the analysis. First, we will begin with the primary standard. Actually, whenever we are going to prepare the different solution, it is always not possible to prepare the solution of the exact theoretical concentration. For example, you may have performed different titrations, that is the titration between the hydrochloric acid and titration between the sodium hydroxide. Now in this case, if we want to prepare the exact concentrated solution of, say for example, 1 normal sodium hydroxide, always it is not possible to prepare exactly 1 normal solution of that particular sodium hydroxide. The solution can be prepared at approximate concentration. Approximate concentration means up to near 1 we can prepare different solutions which are having the different concentration with the help of the primary standard. The concentration, that is nothing but the molarity or normality. We can, as we know, that concentration can be expressed in number of ways, but normally in volumetric analysis mostly we are going to use two different terms. One is the molarity, other one is the normality. So the concentration obtained after standardization is used for further quantitative analysis. Volumetric solution should not differ by 10% from the prescribed limit. So actually, what is the meaning of primary standard? As I said, it is not always possible to prepare the volumetric solutions of desired theoretical concentration. So sometimes these primary standards can be suitable to prepare the solutions which are having the exact concentration. Primary standards are the substances which are obtained in the highest purity and which the standard solution of these primary standards can be directly prepared by weighing these particular substances. So this is the definition for the primary standard. As I said, primary standards are highly pure, stable compounds preferably used for the standardization of less stable secondary standard compound. So first basic difference between the primary standard and secondary standard is that primary standards are obtained in the highest purity. Almost we can achieve a purity of 99.99%. It is not possible to prepare 100% pure substance, but we can prepare the substance in 99.99% purity. So these primary standards are generally having the percentage of purity up to 99.99%. So these substances are known as the primary standards, which are used for the analysis of different secondary standard. Now for a compound to become as a primary standard, there are certain requirements. Just one requirement that I have told you, that primary standard must have a 99.99% purity. But it is not always possible that we are getting substance in 99.99% purity. So these substances are categorized under the secondary standards. So first we will discuss about which are the different requirements that primary standard should have. Primary standard compound should satisfy the following requirements. It must be readily available with less cost. The cost of that particular primary standard must be less and it should be readily available. Otherwise, we cannot use if that particular substance is not readily available at that much frequency. It should be chemically stable. Chemically stable means what? It does not undergo any degradation process in our volumetric analysis. If it undergoes certain degradation process, then that is not suitable or that will hamper our reaction that we are going to perform in that particular case. It should be almost, see here as I said, it is not possible to get the 100% pure compound. So almost we can get 100%, there is nothing but the 99.99% purity can be obtained for certain substances. So primary standards must be available into 99.99 sorry it must be available in 100% pure form as well as in the dry form. The total amount of impurities should not exceed the 0.01 to 0.02%. This is the amount of impurities, means we can get the 99.99% of the purity for a particular primary standard. It should be stable at drying temperature and should be dried before the weighing. It is important to carry out the drying of that particular primary standard before weighing, because what happens, certain primary standards are having some moisture content, and if we take it as it is, then that leads into the false weights, because if moisture is there, automatically the weight of that particular primary standard will be more as compared to what is the actual amount of that primary standard in that particular weighing. So it should be stable at drying temperature and it should be dried before weighing. So this is the another condition for a substance to become as a primary standard. It should not be hygroscopic. Hygroscopic means what? Certain substances, when we keep as it is open in the atmosphere, they will absorb the moisture and they will become wet. So such a substances are known as the hygroscopic substances because they will absorb the moisture from the environment. So primary standard should not be hygroscopic, otherwise it will absorb the moisture and it will tend to increase its weight. The next condition, that it should not be oxidized in presence of air and remain stable in air during weighing. It should not be affected by carbon dioxide. Means oxygen is present in the air, and due to the presence of oxygen, certain substances are oxidized. So primary standard should not be oxidized in presence of the air, which must remain stable in air during the weighing, and it should not be affected by carbon dioxide also. It should be readily soluble under the experimental condition. Means whatever the solvent that we are going to use for the experimental purpose, these primary standards must be readily soluble under this experimental condition. The reaction with standard solution should be stoichiometric and practically instantaneous. That is, must have high rate of forward reaction than the backward reaction. Now, sometimes it might be possible that conversion of the reactant may take place into the product, and after that backward reaction means what? Products are again converted into our reactant. So that the reaction with primary standard must be very quickly and it must have the rate of forward reaction must be more. So these are the few requirements of the primary standard. Then the titration error, with it should be negligible. In practice, it is very difficult to obtain the ideal primary standard and have to be compromised with the above requirements. Now, we will see few examples. Depending upon the which type of volumetric analysis that we are going to use, primary standards that are used are different. Means different primary standards are used in the neutralization titration. Different primary standards are used in the oxidation reduction titration, precipitation titration, likewise. So first here we will discuss only the primary standards that are used in the neutralization titration. Further, the primary standards that are used in a neutralization titration, they are also of two types. One, the primary standards for the acidic titrant, means these compounds are actually basic in nature and they are suitable for titration against the acidic titrant. For example, anhydrous sodium carbonate. As we know, sodium carbonate is a basic compound. So anhydrous sodium carbonate, which can be titrated with the acidic titrant, for example hydrochloric acid, or say oxalic acid, or say for example sulfuric acid. So these are known as the acidic, these are the basic primary standards which are titrated against the acidic titrant. Then for basic titrant, potassium hydrogen phthalate, all these compounds as name suggests they are acidic. Potassium hydrogen phthalate, benzoic acid and oxalic acid. Oxalic acid is also widely used the primary standard for the basic titrant as well as the potassium hydrogen phthalate. Then primary standards that are used in the redox titration, they are also two types as the oxidants, potassium dichromate, potassium bromate and potassium iodate. Then as a reductant, oxalic acid, again here you can see oxalic acid is used as a in neutralization titration as well as the redox titration. Then sodium oxalate and arsenic trioxide. Then primary standards that are used in the complexometric titration, pure metallic zinc, pure metallic magnesium, zinc chloride and calcium chloride. Then primary standards that are used in the precipitation titration, sodium chloride, potassium chloride and potassium bromide. So these are the various primary standards that are used in the different types of the titrations. Then next term that we are going to see is secondary standard. Now as we discussed that secondary standards, these substances which are not available in the highest purity as compared to the primary standard, we can directly prepare the solution of the primary standard, which need not to be standardized. But if we prepare the solution of secondary standard, then compulsory we have to carry out the standardization of it to get the exact molarity or the normality of that particular solution. So secondary standard is a less stable compound generally used for the quantitative analysis and whose concentration can be found by comparison with the primary standard. So concentration of secondary standard can be found by comparison with the primary standard. That is, the titration with primary standard is carried out and molarity or the normality of secondary standard is determined. You have to remember that whenever we are going to prepare the solution of secondary standard, then we have to carry out the standardization against the primary standard. The strength of secondary standard must be determined before actual quantitative analysis of any pharmaceutical compound. Now just we will see few examples. Secondary standards that are used in the neutralization titration. These are the again acidic titrants like hydrochloric acid, sulfuric acid. Then basic titrants like sodium hydroxide. All these compounds are known as the secondary standards. Next we will see the secondary standards that are used in the non-aqueous titration. These are again acidic titrants like perchloric acid, para-toluene sulfonic acid and 2,4-dinitro benzene sulfonic acid. Then basic titrants like tetrabutyl amine hydroxide, sodium acetate, potassium methoxide and sodium amino ethoxide. Secondary standards that are used in the precipitation titrations like silver nitrate, ammonium thiocyanate, potassium thiocyanate, etc. Secondary standards used in the complexometric titration, ethylene diamine tetraacetic acid, that is the EDTA, lead nitrate. Then in redox titrations, potassium permanganate, potassium dichromate, iodine solution as well as the steric ammonium sulfate. Then solutions of accurately known strength are known as the standard solutions, which can be prepared from the primary standard, and from if we want to prepare the secondary standard, then this particular need to be standardized against our primary standard. So here we have